বলতে আমরা জেড বুঝি, ওইটার জন্য এটাকে ইউজ করা হয় বেশি। আচ্ছা, এখন আসি হচ্ছে ডিফারেন্সিয়াল ম্যানচেস্টার এনকোডিং। আগেরটা ছিল ম্যানচেস্টার এনকোডিং, এখন একটা হচ্ছে ডিফারেন্সিয়াল ম্যানচেস্টার এনকোডিং টেকনিক। এখানে হচ্ছে ডিফারেন্সটা হচ্ছে কি, আগে যেমন আমরা এখান থেকে টেনে নিয়ে আসতেছিলাম, এজ তৈরি করা লাগছিল, বুঝতে পারছিল? এই যে এজ মানে আমার টেনে নিয়ে আসতে হচ্ছে, এজ তৈরি করা লাগছে। এখন আমার এই যে ম্যানচেস্টার এনকোডিং এ এজ তৈরি থাকবে। জিরো বলতে আমি এইভাবে জেড এর সাথে তোমার সামনের দিকে একটা এজ বসবে, অথবা উল্টা জেড এর সাথে এমনি একটা এজ বসবে। আর ওয়ানে হচ্ছে কোনো এজ থাকবে না, শুধু জেড অথবা উল্টা জেড বসতে পারে। মানে ওয়ান বলতে জেড অথবা অপোজিট জেড, জিরো বলতে জেড অথবা অপোজিট জেড, বাট এখানে তোমার এজ বসবে। তুমি জেড লেখো, উল্টা জেড লেখো, তারপরে তুমি এই জায়গাটায় ইয়া বসো, এজ বসো। এজ বসালাম, দেখো এটার সাথে এটা ম্যাচ হয়ে যাবে। এখানে এজ বসালাম, দেখো এটার সাথে এটা ম্যাচ হয়ে যাবে। ঠিক আছে? তো এই জিনিসটা হচ্ছে আমাদের ডিফারেন্সিয়াল ম্যানচেস্টার এনকোডিং। আচ্ছা, এখন আমি কিছু এক্সাম্পল করবো তোমার জন্য, তারপরে সলিউশন তোমরা নিজেরাই করতে পারবে। আচ্ছা, আছে 1 0 1 0 0, ঠিক আছে? তো 1 আমি কি জানি, 1 এ কোনো এজ নেই। 1 এ আমি, তুমি বলতে পারো স্যার আমি আপনি এটা ধরলেন কেন? আপনি এটা ধরতে পারতেন, কোনো অসুবিধা ছিল না। আমি জেড ধরেছি, জেড ধরলাম। ওকে, এখন আমার জিরো আছে, জিরো আমি এইটা নিব নাকি এইটা নিব? কারণ আমি এইটা নিব, কারণ আমার নিচে এসে থেমে গেছে। নিচে এসে থেমে গেলে আমার এইটা নেওয়া লাগবে। আমি নিচের থেকে শুরু করব, ঠিক আছে? এই যে নিচের থেকে শুরু করছি, নিচের থেকে শুরু করছি। এরপর আমার ওয়ান আছে, ওয়ানে কি আমার এজ আছে? এজ নেই। ওয়ানে আমার এজ নেই, যেহেতু আমি কি জেড নিব না অপোজিট জেড নিব? অপোজিট জেড নিব, কারণ হচ্ছে আমার নিচের থেকে শুরু করা লাগবে। তারপরে জিরো, তারপরে জিরো বলতে আমি এটাও নিতে পারি, এটাও নিতে পারি, কারণটা কিন্তু আমার দেখা লাগবে কোনটা নিতে হবে। আমার যেটা উপরে থেকে শুরু করতে হবে সেটাই আমার নিতে হবে। উপরে এসে থেমে গেছে, তাহলে আমার এটা চুজ করতে হবে। আবার উপরে থেমে গেছে, তাহলে আমার এটা নিতে হবে। আরেকটা করি, একই জিনিস আমি যদি এইগুলা দিয়ে করতাম, মানে উল্টা এটা দিয়ে করতাম, তাহলে কি হতো? দাঁড়াও, ওয়ান আমি উল্টা জেড নিলাম, ঠিক আছে? উল্টা জেড নিলাম, নেওয়ার পর আমি উপরে থেমে গেছি। উপরে থেমে গেলে আমি কোনটা নিব? এটা নিব না ওইটা নিব? এইটা নিব। উপরে থেমে গেলে এটা নিব। আবার উপরে থেমে গেছি। এখন উপরে থেমে গেলে ওয়ান আছে, আমার জিরো নেই। ওয়ান থাকলে আমি এটা নিব না এটা নিব? আমি তো এটা নিব না, এটা নিব, কারণ হচ্ছে উপরে থেমে গেছে। এরপরে জিরো আছে, জিরো আমি এইটা নিব, কারণ এটা নিচের থেকে শুরু হয়ে গেছে, আমার নিচে থেমে গেছে, ঠিক আছে? তারপর আছে জিরো, জিরো আমার উপরেরটা না, এটা নিব না এটা নিব? নিচের থেকে যেটা দিবি। একইভাবে ওই জিনিসটা করা হয়েছে, দেখে নেবেন এটা, ঠিক আছে? এখন আমি কিছু ডিভাইসের প্রসঙ্গে যাব। ডিভাইস হচ্ছে নেটওয়ার্কিং ডিভাইস, আদারওয়াইজ আমি ল্যাব শুরু করতে পারছি না। নেটওয়ার্কিং ডিভাইস আমরা কি কি জানি? আমরা কেবলস আছে, আমাদের হার্ডওয়্যারের মধ্যে আছে রিপিটার আছে, হাবস আছে, ব্রিজ আছে, সুইচ আছে, রাউটার আছে, রাউটারের পর আরেকটা আছে ব্রাউটার আছে, রাউটার হচ্ছে ইন্টেলিজেন্ট রাউটার, এটা হচ্ছে ব্রিজ ক্লাস রাউটারের ফিচারিং করে। আপনার গেটওয়ে আছে, আপনার আইডিএস আছে, আপনার ফায়ারওয়াল আছে। ওকে, এখন আমি একটা ভিডিও প্লে করব। আমি গুগল লগ ইন ক্রোম দিয়ে ঢুকছি, ঠিক আছে?
Hello everyone. In this video, we're going to talk about the difference between a hub, a switch, and a router. Now, all three of these devices are similar, but there is a difference in the way they handle data. So we'll first talk about a hub. Now, the purpose of a hub is to connect all of your network devices together on an internal network. It's a device that has multiple ports that accepts Ethernet connections from network devices. Now, a hub is considered not to be intelligent because it does not filter any data or has any intelligence as to where the data is supposed to be sent. And that's because the only thing a hub knows is when a device is connected to one of its ports. So when a data packet arrives at one of the ports, it is copied to all of the other ports. So all the devices on that hub sees that data packet. So again, a data packet comes into one port, then the hub will just rebroadcast that data to every port that has a device connected to it. So even if this computer here only wanted to communicate with this computer over here, these other computers would still receive the data even though the data was not intended for them. So when this happens, it not only creates security concerns, but it also creates unnecessary traffic on the network, which wastes bandwidth. Now, a switch is very similar to a hub. It's also a device that has multiple ports that accepts Ethernet connections from network devices. But unlike a hub, a switch is intelligent. A switch can actually learn the physical addresses of the devices that are connected to it, and it stores these physical addresses, called MAC addresses, in its table. So when a data packet is sent to a switch, it's only directed to the intended destination port, unlike a hub where a hub would just rebroadcast the data to every port. So as an example, if this computer here wanted to communicate with this computer over here, the data packet arrives at the switch, and then the switch will look at its table of MAC addresses and matching ports and deliver the data to the correct port, and then the data packet would only go to that computer. So that's the major difference between a hub and a switch. So as a result, switches are far more preferred over hubs, because they reduce any unnecessary traffic on the network. So as a review, a hub only detects that a device is physically connected to it, and a switch can detect specific devices that are connected to it because it keeps a record of the MAC addresses of those devices. Now, hubs and switches are used to exchange data within a local area network, for example, such as in your home network or in a business. They are not used to exchange data outside their own network, such as out on the internet, because to exchange or route data outside their own network to another network, such as out on the internet, a device needs to be able to read IP addresses. And hubs and switches do not read IP addresses. So that's where the router comes in. Now, a router does exactly what its name implies. A router is a device that routes or forwards data from one network to another based on their IP address. When a data packet is received from the router inspects the data's IP address and determines if the packet was meant for its own network or if it's meant for another network. If the router determines that the data packet is meant for its own network, it receives it. But if it's not meant for its own network, it sends it off to another network. So a router is essentially the gateway of a network. So here we have a private network with its router, and we'll refer to this as the red network, indicated by the red colored screens on the computers. And over here you're going to have different data packets, indicated by their different colors, which represents different IP addresses, and they are going to be entering the red network's router from the internet. Now the router is only going to accept the red data packets because they are the only ones that are intended for this network. So all of the other data packets, the yellows, blues, greens, etc., will be rejected by this router because they were not intended for this network because their IP addresses were not meant for this network. Now here is an expanded view of routers over the internet. There are 4 networks here, indicated by their different colors, and each network has their own router, along with their hubs or switches and their computers. So right now, as you can see, each network is just exchanging information within their own network. Their data is not going out on the internet, so they are not communicating with other networks. They are just exchanging data within their own network using their hub or switch. Now let's go ahead and exchange data between different networks. So let's say, for example, that this computer here on the red network wants to communicate with a computer here on the blue network. So for this to happen, the data packet has to leave their own network and go out on the internet. So the computer sends their data, and it goes to the network's router. And once the data packet reaches the router will look at the IP address of the data packet and then forward the data out on the internet to the next router, and then make its way to the blue network's router, and then to the intended destination computer. So in a nutshell, this is how routers work. So in conclusion, hubs and switches are used to create networks, while routers are used to connect networks.
হোপফুলি বুঝতে পেরেছো রাউটার কি কাজ করে। রাউটার হচ্ছে নেটওয়ার্ক তৈরি করে না, রাউটার হচ্ছে নেটওয়ার্কগুলোকে কানেক্ট করে। আর ব্রিজ এবং ব্রিজ না, হাব এবং সুইচ হচ্ছে নেটওয়ার্ক তৈরি করা আমাদের বাসার মধ্যে বা অফিসের মধ্যে। এখান থেকে কারো কোনো কোশ্চেন আছে ভিডিওটা থেকে?
No, sir.
আচ্ছা, আরেকটা ভিডিও প্রায় করছি, সেটা হচ্ছে অপটিক্যাল ফাইবারের উপরে। দেখেন,
Any corner of the world within a blink of an eye? This has been made possible by a network of cables, which are laid under the ground and below the ocean. The cables, which carry most of the world's data, are optical fiber cables. They are also used in medical equipment. Let's learn how optical fiber cables work and how they have revolutionized the world around us. Optical fiber cable is made up of thousands of fiber strands, and a single fiber strand is as thin as a human hair. Optical fibers carry information in the form of light. Let's first learn some fundamental behaviors of light to understand the workings of optical fibers. The speed of light changes when it passes through a medium, and this change in speed is expressed by the refractive index. This variation in the speed of the light leads to another interesting phenomenon: refraction. To understand what it is, let us carry out an interesting experiment. In this experiment, light passes through a prism. You can see that at the interface, the light gets bent instead of going straight. This phenomenon is known as refraction. Refraction occurs when light passes from a medium with one refractive index to one with another refractive index. The light bends towards the interface when it goes from a medium of high to one of low refractive indices. Refraction is the reason why a pencil looks bent in a glass of water. This simple refraction technique is effectively used in optical fibers. Now, let's make this experiment a hypothetical one. Using some dopants, we are able to increase the refractive index of the glass in real time. As we increase the refractive index, the light will bend more and more towards the surface. After a time, you can see that the light will pass through the surface of the glass. If we increase the refractive index further, the light will suddenly come back to the first medium as a pure reflection. This is called total internal reflection. The total internal reflection is possible if we increase the incident angle rather than increasing the refractive index. In this case, at a certain angle called the critical angle. The light will come back to the first medium. This phenomenon of total internal reflection is used in optical fiber cables to transmit the light. The simplest form of optical fiber cable is shown here: cylindrical glass with a high refractive index. If the laser strikes the interface at an angle greater than the critical angle, total internal reflection will happen, and the light will reach the other end. This means that light can be confined in the optical fiber over a long distance, no matter what complex shape the fiber forms. Remember, total internal reflection happens between the high refractive index glass and the low refractive index air. However, optical fibers need a protective coating. A protective coating is not possible with this configuration. The introduction of protective material will replace the position of the air and cease the total internal reflection phenomenon. An easy way to overcome this issue is to introduce a low refractive index glass above the core glass, known as cladding. This way, total internal reflection will happen, and we'll be able to use a protective layer. Both the core and the cladding use silica as their base material. The difference in the refractive index can be achieved by adding different types of dopants. The optical fiber we have just constructed won't be able to carry signals for more than 100 kilometers. This is due to various losses that happen in the cable. This loss of signal strength is generally called attenuation. Absorption and scattering are the main reasons for signal attenuation. This is why you see amplifiers in cables after a certain distance. They boost the signal strength and allow signals to be transmitted over a long distance. The power required for the amplifier is drawn from nearby sources. Now, back to the main topic. How does the optical fiber transmit information such as phone calls or internet signals? Any information can be represented in the form of zeros and ones. Assume you want to send a hello text message through your mobile. First, this word will be converted into an equivalent binary code as a sequence of zeros and ones. After the conversion, your mobile phone will transmit these zeros and ones in the form of electromagnetic waves. One is transmitted as a high frequency and 0 as low frequency wave. Your local cell tower picks up these electromagnetic waves. At the tower, if the electromagnetic wave is of high frequency, a light pulse is generated. Otherwise, no pulse is generated. Now, these light pulses can easily be transmitted through optical fiber cables. The light pulses which carry the information have to travel through a complicated network of cables to reach their destination. For this purpose, the entire globe is covered with optical fiber cables. These cables are laid under the ground and below the ocean. It is mainly the mobile service providers that maintain these underground cables. AT&T, Orange, and Verizon are some of the few global players who own and maintain the submarine cable network. A detailed cross-section view of an undersea cable is shown here. You can see that only a small portion of the cable is used for holding the optical fiber. The remaining area of the cable is a mechanical structure for protection and strength. Now, the question is, where does the amplifier get power from under these deep oceans? Well, for this, a thin copper shell is used inside the cable, which carries electric power along the cable so that the amplifiers can be powered. This whole discussion simply means that if optical fiber cables do not reach a part of the globe, that part will be isolated from the internet or mobile communications. If we compare optical fiber cable to traditional copper cable, the optical fiber cable is superior in almost every way. Fiber optic cables provide larger bandwidth and transmit data at much higher speeds than copper cables. This is because the speed of light is always greater than the speed of electrons. The flow of electrons in a copper cable generates a magnetic field, even outside of the cable, that can cause electromagnetic interference. On the other hand, the light, which travels through the optical cable, is always confined within the fiber. Thus, the chance of interaction with an external signal does not exist. One more interesting feature about optical fiber cables is that any light signal, which enters from the side, has a minimal chance of traveling along the cable. Thus, the optical fiber cables provide high data security. You might be amazed to know that optical fiber was first used in endoscopy, even before it was used in the telecommunications field. In telecommunications, digital pulses are transferred through the optical fiber cable. However, in endoscopic cables, visual signals, which are in the analog form, are transmitted to the other end. We request your support at patreon.com to help us continue our education services, and thank you for watching the video.
Okay, that was very helpful video for all of you. It was very highly animated. খুব clearly দেখানো হয়েছে। ভিডিওর থেকে কোনো কোশ্চেন আছে? আমি কিন্তু ভিডিও থেকে কোশ্চেন জিজ্ঞেস করব। আচ্ছা, একটা কোশ্চেন জিজ্ঞেস করছি। অপটিক্যাল ফাইবার সমুদ্রের নিচে কিভাবে পাওয়ার পায়?
স্যার, ওই যে কপারের একটা থিন লেয়ার থাকে,
ওইটা কি করে?
ওইটা পাওয়ার, ওটার মধ্যে পাওয়ার পাঠানো হয় এবং সাথে অ্যাম্পলিফায়ার থাকে। এই অ্যাম্পলিফায়ার দিয়ে সিগন্যালগুলোকে অ্যাম্পলিফাই করে অপটিক্যাল ফাইবারের মাধ্যমে পাঠানো হয়।
আচ্ছা, অ্যান্সার 90% অ্যাকুরেট হয়েছে। অ্যান্সারটা একসাথে একটু জিনিস অ্যাড করতে হবে। কপারটা ইনসুলেটর হিসেবে কাজ করে, যার জন্য চার্জটা ধরে রাখে, ঠিক না? ঠিক। হ্যাঁ, তোমার অ্যান্সার ঠিক আছে, নো প্রবলেম। তো বুঝতে পারছেন আমাদের ওয়ার্ল্ডের পুরো জিনিসটা আমাদের পুরো ছড়িয়ে ছিটিয়ে আছে। আর আমি CME-V4 CME-V5 দেখিয়েছিলাম, যেটা কিনা আমাদের এর সাথে কানেক্টেড, যে অপটিক্যাল ফাইবার স্টেশন তার সাথে কানেক্টেড। আচ্ছা, একটা মিনিট অপেক্ষা করবেন। করছি এটা হচ্ছে সাবমেরিন কেবল কিভাবে ইনস্টল করা হয় একটু দেখেন।
A message can be sent around the world on the internet in a fraction of a second. The answer lies deep within the ocean. On this episode, we'll take a look at deep sea internet cables. This episode is also sponsored by Backblaze, an automatic online backup service. If you want to check out a free trial, head over to backblaze.com/TTP. While many believe the global internet was made possible by satellites, this simply isn't the case. The internet, believe it or not, is a physical network connected on land and under the ocean. A solution needed to be found how we could connect everyone across the globe. After the invention of fiber optics, this technology soon spread across the world. Fiber optic lines are run from town to town and city to city on land, but when it comes to crossing the ocean, a special cable and ship was needed to pull it. Data is transferred on fiber optics, or these strands of perfect glass with pulses of light. When created, the bidirectional fibers are color-coded, with each color indicating a direction of data flow. Having a cable that lives in the ocean took some specific engineering. First off, the fiber optic strands are the width of a human hair and are coated with gel to keep them in place in this first layer of protection in a plastic tube. Around the plastic tube are steel wires that add needed strength and protection. The next layer is made of copper, which not only adds additional strength, but transfers power to repeaters. Repeaters are these canister-like devices that amplify the light every 50 miles or 80 kilometers, so the signal will make it to the other side of the ocean. The final layer is made of plastic, which insulates the entire package. This is the basic oceanic cable configuration, with cables placed near shallow areas, close to shore, or commercial fishing areas need more protection. 2 additional layers of galvanized steel capped with nylon thread and tar will be added for these areas. These cables are manufactured and spun in giant reels, which go into pans in this large facility. When ships head out to sea, they'll have around 100 pans to finish the job. When it's time to load the ship that'll carry the cables out to sea, a series of conveyor belts called the cable highway pulls the cables into a large spool at the base of the ship's hull. An entire crew working 12-hour shifts for a month is what it'll take to get the ship ready to pull a new internet cable. The ship will make its way to its starting location and get as close as possible to the beach without becoming beached itself. Cable is floated out to shore and then buried in the sand. As the ship starts to leave the coast, a remote-operated plow. This device will bury the cable as the ship moves. Dense, rigid sea floors only require the cable to be buried a small ways underneath. If the floor is soft and gooey, the plow will have to work much harder to embed the cable much lower. Plows like the ROV-6 can perform this work up to 6,500 feet or 2,000 meters below the surface of the ocean. Robotic arms and jets help put the cable into the ground, and treads allow it to traverse on the ocean's floor. These robots are controlled from the comfort of the ship with small-scale replicas. These ships have designated routes already planned where the ocean floor is flat and smooth for easy placement. When crossing places like the Atlantic Ocean, the Atlantic Ridge is an underwater rocky mountain range which requires the cable to be reinforced within that region. Now you might be wondering, do these cables have to be laid in one piece? Can they be repaired if damaged? Do sea life attack these cables? Well, first off, yes, sharks have been known to bite and gnaw on them, but don't typically get through the cables. If they have been damaged, they can be repaired. When laying a new line of cable, commonly there are 2 ships doing this job, one from either side, and they'll meet somewhere in the middle. When they meet, the cables will be fused together, and this is the basics of how we have our internet today. Because of the network of cables being laid, we now have the opportunity to have services like Backblaze, which is our sponsor. First off, I just want to say I contacted Backblaze and asked them if they'd like to sponsor this video, because I want to work with products and services, brands that I love and use myself. Backblaze is a service that automatically backs, and there's really back up my hard drives when it's on your computer, and it'll just update what has changed. Also perfect for a weekly, monthly backup. It was proposed in 1840, with construction beginning in 1854 and completing 4 years later. This cable must have seemed like witchcraft in these days, as the only way of transmitting a message across the Atlantic at the time was by boat, which took 10 days. After the first transatlantic cable was laid, it only took a matter of minutes to communicate with Canada, signaling the project was a big success. But that success didn't last long. The signal quality started to fade quickly, which had the chief electrician of the transatlantic telegraph apply excessive voltage in efforts to increase transmission speed. This ended up frying the cable, making it unusable. New cables were laid in 1857 and 58, but it wasn't until 1865 when a new design of cable allowed for prolonged use. The invention of repeaters, used to amplify the signal along the cable, were first introduced in 1956. 2 cables were laid between Scotland and Newfoundland, one for each direction of communication. Each cable was capable of 35 simultaneous phone calls at once. Amazing to see where we've gone since then. When it comes to underwater data cables, companies with deep pockets like Google, Microsoft, and Facebook will each get 2 threads per ship. 1 thread for each direction of data transfer. In 2016, there were 250 active cables. New cables are being laid all the time, and today, as of the release of this video, there are 443 cables. That's over 621,000 miles or 1,000,000 kilometers of cable laying on the ocean floor. Capable of 10 gigabytes per second for single fiber, or within the entire cable, 100 to 160 terabits of traffic can be transferred, which is around 70 million high-definition videos being streamed at once. With an average depth of 11,000 feet or 3,352 meters below the ocean surface, coral reefs, shipwrecks, earthquake zones, and active volcanoes, and as mentioned earlier, underwater mountain ranges have to be planned for when laying the cable. Today, advanced 3D layouts and real-time metric software called Macaulay are used when laying a cable, which account for the cable's properties and force applied on it within the location, contour of the ocean floor, with real-time ocean currents as the cable goes out. The software can precisely control the retrieval of the cable for repairs. There are a handful of hotspots where many cables converge: New York, Southern Florida, Puerto Rico, U.S. Virgin Islands, Panama, Fortaleza, Brazil, Rio, Sao Paulo, Lagos, Nigeria, Spain, Marseille, France, Southern England, Alexandria, Egypt, Oman, Mumbai, India, Singapore, Hong Kong, South Korea, Japan, Hawaii, and the western coast of the United States. Not only are internet cables hitting the ocean floor, but so are power cables transferring power from offshore renewable energy sources, most predominantly from wind farms. Technology is increasing at a rapid rate. It's been 25 years since the internet was available in households. What technology do you think will arise in the next 25?
Hope you enjoyed this episode. If you're interested in having your data backed up and secured,
the global economy, telecommunications and energy, which includes interconnecting grids, oil and gas, and renewables. This video will discuss the state-of-the-art in submarine cable laying, including the main problems and cutting-edge tools being used by cable installers. First, let's see who is laying submarine cables and why. The telecom industry was the first to lay submarine cables in the 1850s. These cables are the backbone supporting the explosion of the internet, and 99% of the world's international telecommunication travels through them. The subsea power cable industry is currently experiencing rapid growth, spurred on by 2 main factors: the emergence of offshore renewable energy, especially offshore wind, and the increasing demand for grid interconnection between networks with excess electrical supply to others with excess demand. With energy prices rising, seismic oil exploration is being pushed into deeper offshore fields, requiring the ocean bottom cables to be laid and retrieved very accurately in even deeper waters. Cable laying techniques before the 1990s were still relatively crude, leading to cable failures. The basic issue was this: cable installers didn't have a good picture of what the cable was doing below the surface. Then, in the late 1980s, Mackay Ocean Engineering presented a solution. With modern computers, Mackay developed a rigorous 3D model of the cable, called Mackay Lay, that accurately computed and displayed the cable shape and touchdown conditions in real time. The Mackay Lay model can take into account the cable properties, all forces on the cable, the seabed contours, the ship maneuvers, and even ocean current readings from a current profiler in real time during the lay. Operators use Macaulay software to monitor and control the cable's position and bottom tension, allowing them to optimize the vessel navigation and cable payout instructions for a safe and swift cable lay. These two variables, position and tension, are of the utmost importance for a cable lay. Macaulay provides control over the cable's position and tension at any depth. Here's how. During a lay, Macaulay gives the vessel and cable engine instructions to keep the cable right on track, and it retains a log of the as-laid path. For power cable lays, Macaulay can place the cable on the seabed with high accuracy and can minimize or eliminate the need for expensive ROV touchdown monitoring. In addition, Macaulay can precisely control the retrieval of cables to minimize lateral dragging and damage. Retrieval speeds with Macaulay can be easily doubled, minimizing ship time and repair costs. Installing any type of cable with high slack can result in using more cable than is necessary and increase the chance of unwanted loops. Also, laying a power cable with low tension or slack could result in a damaging kink at the touchdown. On the other hand, installing a cable with tension that is too high will result in suspensions leading to extreme forces at the contact points. This exposes the cable to higher current forces, which vibrate the cable, causing wear and in some cases failure at the heavily loaded contact points. Macaulay provides tension control for power cable and flexible pipe installations where a residual tension at the seabed is needed. A feature called auto tension automatically adjusts cable payout and vessel navigation to keep tension within acceptable limits, paying out cable faster when it is too high and vice versa when it is too low. In 1989, Macaulay was first used to install a power cable through a treacherous and narrow corridor in deep waters. This remains the highest precision deepwater power cable lay in the world to this day. Since then, Macaulay has become the #1 subsea cable installation package in the world, used by over 75% of the world's subsea cable ships. And although Macaulay is for use on a vessel at sea for real-time installation and repair, Macaulay has developed other very popular tools for route engineering, simulation, and training for power, telecom, and seismic cable projects. Macaulay allows you to get your cable lay right the first time, minimizing the need for costly repairs and thus maximizing profits for owners, insurers, and installers. Visit us at www.mackay.com to learn how Mackay's tools can help you with your
Okay, there was very useful 2 videos. আচ্ছা, এই ভিডিওগুলা যতগুলা শেয়ার করেছি আজ পর্যন্ত এই সহ আপনাদের নেক্সট ক্লাসে একটা কুইজ হবে। আদারওয়াইজ সামনের উইকে আরো এসে পড়তে পারে পরীক্ষা আপনাদের। তো বলে দিচ্ছি কোন কোন এই পর্যন্ত যতগুলা ভিডিও দেখিয়েছি সবগুলো সহ আর কি। উদাহরণ বলে দিচ্ছি। অপটিক্যাল ফাইবার, ইথারনেট কেবল, হাব সুইচ, রাউটার, আইপি অ্যাড্রেস না, এগুলা সহ আর আজকে যে এনকোডিং টেকনিকটা দেখিয়েছি সেটা সহ আজকের পরীক্ষা হবে এই পর্যন্ত। আচ্ছা, আমি ইন দ্য মিন টাইম লেকচার একটু শেয়ার করে দিচ্ছি, একটু হোল্ড করবেন। ওকে, আমি ভিডিওগুলো শেয়ার করেছি যতগুলো পর্যন্ত হয়েছে আজকের ক্লাস সহ। আচ্ছা, আমি কিছু আগাচ্ছি।
স্যার এক্সামটা নেক্সট সানডে নিলে হয় না?
তাহলে কি মঙ্গলবার দিবেন? মঙ্গলবার দিয়ে দেন ল্যাব আওয়ারে।
ওকে স্যার।
যত ছোট সিলেবাস ভিডিওগুলোর উপরে আর যতটুকু একটু পড়িয়েছি, ডেফিনেশন থাকবে না, ডেফিনেশন আমি দিচ্ছি না। আচ্ছা ঠিক আছে, আমি কুইজ তাহলে রোববার দিনই নিব, তাহলে সিলেবাস আর একটু বড় হবে, থার্সডে ক্লাসটা ইনক্লুড হবে।
জি স্যার, ঠিক আছে।
আচ্ছা, আপনাদের আরেকটা কথা হলো, এখন আপনাদের মঙ্গলবার দিন ল্যাব আছে, আর ল্যাবটা শুরু হবে ঠিক 8:30টার সময়। ঠিক আছে, ল্যাবটা শুরু হবে ঠিক 8:30টার সময়। আচ্ছা, আজকে এই পর্যন্তই। আমরা নেক্সট ক্লাস
স্যার লেকচার স্লাইড আপলোড দিলে স্যার ভালো হতো। আপলোড কি দিবেন?
কোনটা?
স্লাইড, লেকচার স্লাইড।
ও আচ্ছা, লেকচার স্লাইড দিয়ে দিচ্ছি।
ওকে
ঠিক আছে।